All right, example 2. I'm going to follow the exact same process that I just did a moment ago. It's still written on your paper right in front of your face there, so I'm not going to write it down again. But I'm going to go through the process with this problem. First thing is I want proper structure of the problem, which is everything equals 0 in descending order. So the first thing I'm going to do is I'm going to move the 3x over to the left. So I'm going to do x squared minus 3x plus 9 equals 0. Always start at the same place, then everything works out exactly as it's supposed to. All right? So I slid the 3x to the left, the sign changed. The x squared and the 9 didn't move, so they stayed positive x squared, positive 9. Only things that move across the equal sign change signs. Next, step 2. Divide by a if necessary. A is 1 again, so it's not necessary. Step 3. Move the constant to the right, leaving a gap. So x squared minus 3x gap equals negative 9.
Why does the 0 get there?
What, say again?
Why does the 0 not go
Oh, well, if you move the 9 over, so it's chop minus 9, right? What's 0 minus 9? Right. So you're going to have a 0 there. Whatever you throw over there is going to add to 0, then the 0 is irrelevant at that point. Okay? So, now we're at our magic number step, and then we're supposed to take half of b, right? And square it. So here's a couple things about this. Squaring anything always makes a positive. So whether b is positive or negative, just pretend it's positive when you're doing the step. And for me, if it's going to be a fraction, here's what I do. On my paper, in the gap, I'm going to write parentheses 3 over 2 squared. I'm just going to write it out. Again, you can write negative 3 over 2 if you want to, but when you square it, you're going to get positive anyway. So for me, it's easier just to write as a positive in this step. But again, whatever b is, which in this case, b is 3 over 2 squared. All right? On this side. On that side, I'm going to actually square it. And I'm going to leave a little space here. Just leave a little extra space there. You'll see why in a second. And on this side, I'm going to actually square it. So to square a fraction, you just square the top. 3 times 3 is 9. You square the bottom, 2 times 2 is 4.
Isn't the b negative 3?
It is, but again, negative 3 times negative 3 is still positive 9. So again, this is always going to be positive anyway. So just to avoid any confusion, I just always put b positive.
So is the b negative though?
It is negative, yes, it is. So again, just to clarify, because I'm breaking the rules a little bit here. So I want you to understand why I am. If I put a negative 3 over 2 squared, negative 3 times negative 3 is still positive 9. It's the same effect whether it's positive or negative, and it's easier for my brain not to have a minus sign in the problem. So I'm going to pretend b is positive every single time on these problems.
But the equation...
But in the original equation, absolutely, b is negative 3, absolutely, yes. All right? So now, here's the reason why I left this little space here. If this is a fraction, it requires fractional addition, right? And if I want to add negative 9 to 9/4, I need negative 9 over 1, which is what it officially is, to have a fourths. I need to be over 4, right? So times 4 on top, times 4 on bottom, which gives me negative 36 over 4. This right here is the same as negative 36 over 4, but negative 36 over 4 is more useful to me, right? So the negative 9, create a common denominator, and then I'm going to just scribble out a little bit. Not so much that I can't read what was written there, but enough that it's not going to be in my thoughts anymore. Negative 36 fourths equivalent to negative 9, that's more useful. So now I'm in my factor step, right? It says factor the left, add the right. So on the left-hand side, again, just to clarify, every single time this is how we factor it. Put a parentheses squared. There are 3 objects to go in the parentheses. Object 1 is whatever this is without the square on it. That's what goes here. Object 2 is whatever this is, square rooted, or in this case without the square on it, so 3/2. All right, if you actually square it, you have to take a square root. If you have something squared, then you just write the something. Object 3 is whatever this sign is, goes in between.
So is it not squared in the parentheses because it's already squared on the outside?
Well, I mean, if I squared it, it's 9/4, right?
Yeah.
And the square root of 9/4 is 3/2. If I write it as 3/2 squared, I just chop the power off.
Okay.
So either way, you're gonna get 3/2 out of it, but again, when I'm dealing with fractions, not to square it and then have to square root it again, it's easier just write it as object squared, just take the power off. Object squared, just take the power off, take the sign. So again, just for ease of use, it's better to write it as fraction squared when you have a fraction to deal with. When you have a number squared, like 4 squared 16, square root of 16 is 4, that's easy, right? I could have just as easily written 4 squared here, drop the square. It means the same thing, right? So again, for me, anytime I deal with fractions, this just avoids a lot of confusion to do it that way. So that's why I write it that way. Over on the right-hand side, I have a negative 36/4 and a positive 9/4 makes negative 27/4. Let me put one disclaimer on this. Sometimes this is a fraction over here. I'm going to put this, I'm going to write it big enough that it seems important.
So let's answer it.
No, it's not, I'm not done yet. That seemed like an important thing? Never ever reduce that. You wouldn't be wrong if you reduced it, you just make the problem like 55,000 times harder. So don't ever reduce that fraction, ever. Never, ever, ever reduce that fraction. Okay? So, I like that pen. I'm going to use that more often. It's my emphasis pen. So, if I continue on. Next step says to square root both sides, right? So on this side, I take the power off, so x minus 3/2 equals. On this side, I take the square root, so I'm going to get plus or minus the square root of negative 27 on top over 2. In fraction world, you square root the top, you square root the bottom. That's how you take a square root of a fraction. Okay? The top may or may not be a perfect square, but the bottom will always be a perfect square. Always. That's why you don't want to reduce, because if you reduce, maybe it gets rid of the perfect squareness of it. This one didn't reduce anyway, so it's irrelevant, but sometimes it will. Don't ever reduce that. Notice that I made this fraction bar long enough so it did not look like the 2's under the radical, right? Plus or minus the whole thing on top. Now, I think you guys learned in Algebra 1, you should have learned in Algebra 1, when you have a square root. Whatever degree 27 is negative 1 times 3 times 3 times 3. Right? And what you should have learned in Algebra 1 is when you have that structure, if you have a pair of factors, you can pull one out, right? What we learned a few days ago is when we have the square root of negative 1, it makes what? What does negative 1 in the radical make? What's the square root of negative 1 the same as? I, right? So the square root of negative 1 is I, right? So, the square root of negative 27 on top is simplified as 3i times the square root of 3. So, down here on my last step, when I move my 3/2 over, I'm going to get positive 3/2, plus or minus. Instead of writing the square root of negative 27, I'm going to write 3i times the square root of 3 over 2. Because again, that's how the square root of negative 27 simplifies. When radicals simplify, you should simplify them every single time. If either of these fractions reduce, by all means do it. That's the only place where you don't reduce the fraction. In fact, that's the only mathematical thing I can think of where reducing a fraction makes things worse for you. Almost every time reducing fractions is great. That's not one of those times.
You know how it's negative 3x minus negative 3 over 2 squared in the red parentheses?
Yes. Right here, yes.
Yeah. How did that go from squared to, and it stayed negative 3 over 2?
I did square root, square root. So when you have a parentheses squared, the contents of the parentheses are being protected by the parentheses. So when I take the square root, the power goes away, and we're left with the contents, whatever that is. Right? If I were to square it out, I'd multiply this times itself, right? I'd get a negative 3/2 x and a negative 3/2 x.
So you just square root of negative 27 and 4?
Yeah, you take the square root of this side and this side, but the square root on this side just drops the power.
Okay.
So I'm square rooting both sides, but it has a different effect on both sides. So on this side, the power disappears. On that side, you put a square root symbol on it.
Okay.
And again, what does have a perfect square root, like 4, take a square root of. And again, when you have a fraction there, it will always reduce. All right, I do not have enough time to finish this lesson, so I will finish this up on Monday. If you would attempt homework problems where the coefficient of x squared is 1, do not attempt ones where it's not. And I picked out some of each. So if you go through the homework, try some, get good at the idea of it, so when we get to do the fraction ones, you'll be more capable of doing it. It won't seem as hard. All right?
Is it